Friends, today we will discuss about the slope deflection equation, slope deflection method, that is slope deflection method. Slope deflection method. You know that we have studied in determinate structure. You know the difference between determinate structure and indeterminate structure. This one is used in analysis of, this is developed by, presented by Professor George A. Manet. George A. Manet in the year 1915. This method is used to analyze statically indeterminate analyze statically indeterminate beams and frames. Indeterminate beams and frames with rigid joints. The sign conventions. For any end span, clockwise moment, clockwise slope as positive slopes and positive moment. Here, that is, if you consider an intermediate span, here this one is subjected to any type of load. This one is an intermediate support. Here the moment, if the moment is, here the moment is this one is clockwise moment, this one is clockwise moment, this one is positive moment, this one is positive moment, and this moment, that one is negative moment. Similarly, the slope, here this will undergo deformation like this will undergo deformation like this. This slope, this one has theta A, negative moment, positive moment, positive slope, this one is negative slope, theta B. This one is A, this one is B, this one is negative slope. Then downward deflection, downward deflection at the right end, at right end of span with respect to left end this deflection, this is positive, delta is positive. Here with respect to left support, the deflection at right end of span with respect to left end, that is downward, this one is positive. Then for beam or for horizontal member, for beams, for vertical members, for vertical member deflection of upper end towards right side, towards right with respect to lower end, delta is positive, that is here this one is lower end, this one is upper, this one is the deflection, it is like this. Here this one is the deflection, delta is positive. Here you know the sign convention. Then derivation of this equation. Here you may consider any span, intermediate span, let AB be any intermediate span of continuous beam subjected to an external load system theta A, theta B, the slopes at ends A and B. Here this one is deflection. Here this one is the interior support, which is subjected to the loads here, which is subjected to the loads as shown in figure W1, W2. Theta A is the slope at end A. Due to the application of the load, it will undergo deformation like this. Then here, this one is subjected to load. Because of the load, it will undergo deformation like this. Then this one is the slope at B. If you draw the tangent to the deflected shape, here you will get the slope at theta B, that is clockwise. Here this end is B, and with respect to the left end, the right end will undergo deformation delta in downward direction. All are positive. Similarly, if you consider only this intermediate span of this beam, here that is considered as the fixed beam. Here it is subjected to the fixed end moment, that is MFAB, under the action of the loads, external loads. This one is anti-clockwise. Similarly, at end B, this one is MFBA. Here these are the fixed end moments. Consider this AB as a fixed beam. Consider AB as fixed beam. As fixed beam carrying given load system. Given load system. MFAB, MFBA are fixed end moments. Fixed end moments. At ends A and B. Now we can release this fixity at A. Now release the fixity at A. Now release fixity at A. Maintain fixity at B. Here we have to release the fixity at A, and we have to maintain the fixity at B by applying a moment, 4EI theta A by L. 4EI theta A by L at A, which induces to produce lobe. If you remove the fixity, then it will undergo deformation due to this moment, that is 4EI theta A by L at A. Then the slope is here, which will induce 50% of this, which will induce a moment of 2EI theta A by L at B. Here the moments are, this one is, we can release the fixity at B, then this one will undergo deformation. It is like this, that is 4EI theta A by L. This one is A, this one is B. Then here this moment is This one is theta A, the slope produced due to the moment. That one is here. This one is 2 ei theta A by L. Similarly, release fixity at B. Fixity at B, maintain fixity at A by apply a moment of 4 ei theta B by L at B to produce theta B at B, which will induce a moment of 2 ei theta B by L, as shown in figure. This one here, this one is fixed, this one is here. The deflected shape of this one is this one. This one is theta B. This one is clockwise, that is 4 ei theta B by L. This one is 2 ei theta B by L. This end is A, this end is B. Then this is slope. Here this is the deflected shape. Similarly, maintain fixity at A and B to produce a vertical deflection at B, deflection delta at B with respect to A. For this, the moment at each end is 6 ei delta by L. Where L is the length of the beam. This one is L. The distance between the two supports is L. That is length of the span or the length of the beam. What we have considered span is L. Then final moment at A. Final moment at A. MAB equals, first one, MFAB plus 4 ei theta A by L plus 2 ei theta B by L minus 6 ei delta by L square 6EI delta by L square. Then here this give us M of AB plus 2EI by L is common, 2 theta A plus theta B minus 3 delta by L. Here this is equation number 1. MBA equals MF BA plus 2EI by L 2 theta B plus theta A minus 3 delta by L. Equations 1 and 2 are equations 1 and 2 are known as slope deflection equations. Slope deflection equations MAB in general MAB equals MFAB fixed end moment plus 2A by L AB 2 into near end slope plus 1 into far end slope minus 3AI 3 delta by L. This is general equation. Okay, here this is the derivation of the slope deflection equation.